Hi, my name is Jesus Limon. I am doing the LCA on the hooded sweater. All right, so what is the product? So in this case study, the LCA is using cotton, which is the main component of using a hooded sweater. The hooded sweater is used globally all around the world, primarily in colder weather, but it is still used worldwide daily. Uh, the hooded sweater is very important due to its huge contribution to comfort in clothing, but also contribution to using tons of water with having to harvest cotton and grow cotton. In this LCIA, the production of the cotton hooded sweaters are being highlighted. So what is the goal and scope of the LCA? In this LCA, it is used to measure all inputs and outputs of a certain good in in this case, it's going to be the hooded sweater. One of the main scopes is where it's manufactured, most likely like the location, specifically organic cotton, which is widely distributed by India. And there are many different aspects that go into the scope, like user behavior, which is like number of washes, the washing machine load, or the type of dry that you put for your hooded sweater. And the overall scope, boundary, and the flow is shown at the bottom. It shows organic cotton, which is the textile production in India, the zipper production in India, and the polyester resin production in India. So most of these contribute to water waste and just waste in general. However, in the foreground system, like the actual main manufacturing components are the actual manufacturing factories and the distribution. So transportation and overseas transportation to use in Germany as well. And its end of life would be, in this case, any country or end origin for the sweater, depending on the consumer. So the LCI summary is there's raw material, which is the weight of the actual sweater, the brass and polyester production, which has also contributed to a lot of the LCIA assessment that we are going to look at in a little bit. The fabric production, which primarily leads to waste as well, with all the cotton that isn't used and processed. There's manufacturing, which accounts for 11.8% of waste, electricity consumptions from machines that are used, like sewing machines and the cotton production machines. It is very important to note that the distances are pretty long between the cotton harvesting and factories where it's manufactured, along with distribution, which is mainly for manufacturers outside of Europe. And again, it is far with overseas, and then you contribute to the high carbon emissions. So in consumer use is basically the weight total, which is equal to the weight of the sweater, the number of washes, which is multiplied by machine capacity over the filling. And basically the weight is the weight it holds on the environment. And then these are some of the hotspot analysis for the impact. As you can see, we have topics like acidification, climate change. We have human toxicity that's cancerous or non-cancerous, land use, ozone depletion, which is very high in raw materials. And the raw materials are primarily like the brass that is used for for the holes for the sweater. And by the scale of 1 through a higher number, one is ranked to be the worst, while the highest numbers are ranked to be the best. As you can see, the products are assessed and they are normalized and weighted by the equation that I showed just before. And it is ranked to see that high impact of environmentalism, that like its true impact, one being it has the most impact and it needs to be fixed. Meanwhile, the green, like 16, which is ozone depletion, shows that it is something that isn't too urgent to be working on compared to actual climate change, which is due to machinery and emissions. So my interpretation for the limitations of the LCIA model is the fact of having to choose the scope, which is very specific and in turn doesn't really idealize the true impact on the environment globally as a whole. I feel like we have to take into account how well the production is being conducted and if they are staffed well enough, if in order to carry out efficiency, or if they're actively looking for ways to improve the industry of hooded sweaters. Another notable limitation would be the type of hooded sweater and the quality of the hooded sweater. There are many different production ways to produce a hooded sweater. So depending if it's primarily polyester, cotton, cashmere, it is each impactful in its own way, just due to production, location, technology, all that stuff. And I think the LCA process is a good use for guidance in a general positive direction, since we can allocate resources and support where it is needed, and using the LCIA to focus on areas that are generally affecting our environment daily and ways to fix or improve the issue in specific regions. And then here is a machine wash electricity consumption for the hooded sweater graph. As we can see, these are the different, these are the same assessment principles like acidification, human toxicity, cancer, non-cancerous, and such, and the water usage as well, just based on the load in the cycle. So we have the base case, full load, less cycles, tumble dryer. So it just depends on the dryer. So if you use a tumble dryer, you're pretty much going to be consuming 100% of all of the categories, which is a very huge problem, and it needs to be fixed. And then that is all. Thank you so much for listening to my LCA presentation.